Now we turn to the call stack in memory. Let us see where these frames really live while the recursion runs. Your turn. Let us think about the call stack together. Picture a pad of sticky notes. Each call adds a new note on top. Each return takes the top note off. You cannot touch a lower note until the notes above it come off. Look at the chain of calls. Factorial of 4 calls factorial of 3. That calls factorial of 2. That calls factorial of 1. First question. At the deepest point, how many notes are stacked? How many frames are alive at the same time? Second question. In what order do the values come back? Which one returns first and which one returns last? Pause the video and make a guess for both questions. Now the answer. 4 frames are alive at once from factorial of 4 down to factorial of 1. The values return deepest first. 1, then 2, then 6, then 24. The last note added is the first taken off. That is last in, first out, the same rule as the stack in Chapter 6. Let us watch the call stack grow, 1 frame at a time. The program starts by calling factorial of 3. The computer builds a frame for this call. The frame stores one value. It holds n is equal to 3. Now look at the return value. It says pending. Factorial of 3 cannot finish yet. First it needs the answer to factorial of 2. So factorial of 2 is called. A new frame appears just below the first one, at a lower address. This is what we mean when we say the stack grows downward. This frame holds n is equal to 2. Its return value is also pending. It needs factorial of 1, and the frame for factorial of 3 is still there, still waiting. One more call. Factorial of 1 is pushed, even lower. This frame holds n is equal to 1. Factorial of 1 is the base case. It returns 1 right away. It does not call anything else, so no new frame is added. The stack is now 3 frames deep. Now the frames return from the bottom up. The frame for factorial of 1 is freed the moment it returns. The frame for factorial of 2 is on top now. Factorial of 2 can finish. It computes 2 times 1, which is 2. It is about to return that answer up the stack. Factorial of 2 returns and its frame is freed too. Now factorial of 3 can finish. It computes 3 times 2, which is 6, and returns that to main. The stack is back to just main. 3 calls going down, 3 answers coming back up. Let us name the shape we just saw. Recursion has 2 phases. The stack grows, then it shrinks. Let us look at each part. First, the descending phase. Each call pushes a new frame at a lower address. The stack gets deeper. It stops at the base case. This is the deepest point. Here no new frame is added. Then the unwinding phase. Each return pops its frame and hands a value up to the caller. This whole chapter is one memory picture. Push on the way down, then pop on the way up. In Chapter 6, you saw push and pop for a stack you built yourself. Recursion is the same idea, but now the runtime pushes and pops the frames for you on every call and every return. Now a quick check. In the trace above, which factorial frame is freed first and which is freed last? Pause and think. Now the answer. Factorial of 1 was pushed last, so it frees first. Factorial of 3 was pushed first, so it frees last. Frames pop in the reverse order they were pushed. That is last in, first out.